All right, in the last lesson, we looked at a relationship between 2 points that are a reflection. And we saw that they were the same distance from either the x-axis or the y-axis. In this lesson, we're going to look at 2 points again, but now we're going to look at finding the distance between those 2 points. So go ahead and let's review the answers to the do now. You can go ahead and turn to that page, please. So after plotting these 2 points, 4, -3, and -5, -3, I want to find the distance between these 2 points. So I just counted the squares. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's one way of finding the distance. We're going to do it a little bit more mathematically. So go ahead and turn to the next page, and we're going to see how to do this. Again, a little bit more mathematically than just counting the squares. We're going to look at 2 different situations. One is finding the distance between points that are in the same quadrant and finding the distance between points that are in different quadrants. So we're going to start with the different quadrant situation. And we have some steps to help you do that. So the steps are: determine which coordinate is the same and cross it out. Circle the number that is different in both coordinate pairs. And then find the absolute value of each number. And then you're going to find the sum. And that's really the key to this problem. When the points are in different quadrants, you're going to find the sum. So let's take a look at this example. Find the distance between 3, 2 and 3, -4. So I've plotted those points for you already. That's 3 over 3 up 2 over 3 down -4. And let's look at step 1. Determine which coordinate is the same, x or y, and cross it out. So you can see that in this example, the x-coordinate is both 3, so we're going to cross that out. Then it says circle the number that is different in both coordinate pairs. So the y is different than the -4, of course. Then find the absolute value of each number, and we're going to write an expression. So we're going to take the absolute value of 2 and the absolute value of -4, and because they are in different quadrants, we are going to find the sum. Remember, absolute value makes any number positive. If it starts out positive, it stays positive. If it starts out negative, it becomes positive. And that makes the answer to our question 6. And just for the fun of it, let's count the squares between them to see if that's correct. So 1, 2, 3, 4, 5, 6. So you can see that our answer is correct, and the distance between these 2 points is 6. All right, so now let's look at the situation where the points are in the same quadrant. So go ahead and turn to the next page, and we will see how to deal with that situation. So you'll see that the process is pretty similar when they are in the same quadrant. And the main difference is you're going to go through the same process, except in the end, you're going to find the difference between your 2 numbers, not sum them. All right, so let's just go right to the example here. And I've already plotted the points for you. We have -4, 3, so -4 up 3, and -1, 3, -1, 3. Both of these points are in quadrant 2. So let's follow the steps that we have here. Let's see, determine which coordinate is the same and cross it out. So we have the same y coordinate in this problem. So we're going to cross that out. We're going to circle the numbers that are different. So the x coordinates are different. We're going to find the absolute value of each circle number. So I'm going to find the absolute value of -4 and the absolute value of -1. And the difference here is, once we find those, we're going to subtract them. So the -4 becomes 4, the -1 becomes 1, and the distance becomes 3. And of course you can see that that's the correct answer because we have 3 squares between our 2 points. And when you see a problem like that, you can probably just count the squares and get the answer. But there's going to be situations where your numbers are much, much larger, and you have to do it mathematically because you maybe can't fit the points on the graph. Maybe their coordinates are too large to fit on a graph like this, so you're going to have to figure it out mathematically. All right, well, let's go ahead and summarize what we're talking about here. So go ahead and turn to the next page, please. All right, so once again, if your points are in the same quadrant, find the absolute value of the coordinates that differ and subtract. Same quadrant, subtract. Points that are in different quadrants, again, find the absolute value of the coordinates that differ, either the x or the y, and add. So different quadrants, add. All right, so let's take a look at some examples of this and see how this works. So we have a few points on this graph to deal with, so we're going to use those to answer these questions. So let's take a look at question 1. What is the distance in units between points A and B? All right, so we have point A and point B. First of all, note that they are in different quadrants. So the first thing I need to really know is what are the coordinates for A and B. And let's write those up here. So A has coordinates, let's see, it looks like 5, -2. And B has coordinates, looks like 5, 4. So if we put this through the process, the x coordinates are the same, so we're going to cross those out. The y coordinates are different. And really, what I'm about to do answers question 2, so we're going to do that one first. So I want the absolute value of the first one. And again, they are in different quadrants, so we add, and we have the absolute value of the other coordinate, and that gives us our answer. So when we evaluate that, of course, the distance we get is 6, because that's 2 and that's 4, and we add them together. And again, you can count the squares, and you'll see that that is correct. All right, let's look at question 2. Now we're talking about points C and D, and it wants to know the distance and the expression. So really I prefer to do the expression first to calculate the distance. And I had to be careful counting the squares for this one because they're so far apart. It's a little bit easier to make a mistake when you're counting that, so we're going to really depend on the mathematical technique here. But of course we need the coordinates for C and D. I'm going to put those down here. So C is 8, 4, it looks like. And D is -10, 4. And let's follow the steps. I'm looking for the coordinate that's the same. So they both have the same y coordinate. We're going to cross that out. We're going to circle the coordinates that are different. And then I'm going to take the absolute value of each one of those. So once again, they are in different quadrants, so we're going to add. So we have the absolute value of 8 plus the absolute value of negative, I'm trouble making that negative there, 10. And we're going to use that to find the distance. Of course, that's 8, that's 10. So our distance for question 3 is 18. All right, and then finally, question 5. what is the distance between B and C? So we have those 2 points, and let's write them beside each other again, though. So we have B, we already saw was 5, 4. And C, we see is 8, 4. All right, let's go through the process. So I'm looking for the coordinate that's the same. They both had the same y coordinate, so we cross that out. They have different x coordinates. So because they are in the same quadrant, right, B and C are in the same quadrant, we take the absolute value and we subtract. And you want to take the larger number first. So I hadn't really talked about that, but that's going to be helpful to you. So we're going to do the absolute value of 8 minus the absolute value of 5. And of course that's simply 8 minus 5. And that gives us a distance of 3. So that's a good point. Whenever you are doing that subtraction, you really want to take the larger absolute value and subtract the smaller one, because distance is always going to be positive. All right, let's go ahead and turn to the next page and give you a chance to practice some of this. So go ahead and pause the video and work on questions 1 through 4, and then come back and check your answers to see how you did. All right, go ahead and check out these answers. And there was a problem with question 3 because A and B were the same. I'm pretty sure one of these 7s was meant to be a negative, because that's what we would do, right? We would take the absolute value of the differing coordinates, -7 and 2, and they would be in different quadrants, so we're going to add them. So I changed that 7 to a negative because I think that's probably what it was supposed to be, and then that would be the correct choice. All right, so check those answers out. If you got something different, see if you can figure out where you went wrong. Otherwise, you can go to the next page for more practice. All right, go ahead and pause the video and work on questions 1 through 6, then come back and check your answers to see how you did. All right, check out these answers, and the only one I wanted to bring your attention to was number 5. This was kind of a funny question. Hanji believes that point T is -3 units away from the y-axis. So if you look at point T, you see that it's 3 away and in the negative direction, but you don't talk in terms of being a -3 units away. If you're talking about distance, distance is always positive. So if it said that Hanji believes that point T is 3 units away, I would say, yes, we're good to go. But you don't say that something is -3 units away from the y-axis. All right, go ahead and turn to the next page, please. All right, go ahead and pause the video and do this quick problem, and then come back and see how you did. All right, go ahead and check out this answer. This one was pretty straightforward. And go ahead to the next page and you can complete the video assessment. So this assessment's a little trickier than some of the ones you've had in the past. So just please check out my warning to make sure that you calculate the length and the width correctly. And also remember that perimeter of a figure is the length all the way around. Okay, that's what perimeter means. So you have that paper if you are watching this video in class, so go ahead and complete that. When you're done, you can turn that in and you can begin working on your homework if there is time remaining. All right, let me know if you have any questions.